So today comes at the request of one of my students, and somebody's requested it, more than one person requested it, and they wanted to look at ratio and proportion. So we're going to look at ratio and proportion, and we're going to look at converting things from fractions to decimals to percentages, and also some questions using decimals, simplifying fractions. So we're going to look at some foundation level ratio and proportion essentially. So I'm going to pull up a whiteboard and work through some questions. So let's start off with, just make this a bit bigger and move that. Let's move that so anyone watching it on TikTok can see the whole screen. Okay, so let's think about equivalent fractions, decimals, and percentages. So when we have a fraction is a part of something bigger. So when you've got a fraction, say you have half of something, the bottom bit of the fraction, sorry, I'm not sure why it's not writing. So if you've got a half of something, the bottom bit of the fraction tells you what it's out of. So here we've got, essentially we've got one bit out of 2. So half of it would be 1 part out of 2. As a decimal is always out of, if you remember when you did this earlier at school, you would have had hundreds, tens, units, then you get a decimal place, and then you get tenths, hundredths, thousandths. So a decimal is making something either over 10, over 100, or over 1,000. Or you can just divide it. So a half, well, we know as a decimal, that's going to be 0.5. And then to make it into a percentage, we're timesing it by 100 and we get 50%. So percent looks like out of 100. So whenever you see a percentage sign, it's something out of 100. And when we've got a decimal or a fraction, to convert that into a percentage, we're multiplying it by 100. So let's take a few examples and first just go and have a look at fractions, decimals, percentages, and converting between them. So we'll take a few. So if we have fraction, decimal, and percentage, and we're just going to start off doing these and then work up to some more difficult questions. Percentage. So let's try go between these three. So we started off with a half, which we said was the same as 0.5 because it's 5 out of 10, which is 50%. So say we get a decimal that's 0.6. Now we know that first bit after the decimal point means it's out of 10. So as a fraction, this is 6 out of 10, but it's not in its simplest form because both the top and the bottom are even numbers. So we're going to divide the top and the bottom by 2, and we'll get 3 out of 5. Now to go to a percentage, we're going to times by 100. Now remember, when you times a decimal by 100, what you do is you're moving this decimal point 1, that's timesing it by 10, and another, that's timesing it by 100. And when you've moved something and you want to move it again, essentially you're adding a 0. So 0.6 would be 60%. Okay. Now, if we were given the percentage, so we're given 15%. So we're going to divide it by 100. So move the decimal place or move it 2 backwards to give us our decimal. And then we know that's the same as 15 over 100. Because we've got 2 numbers here. So this was 5 out of 10. This one was 6 over 10. But because we've got 2 numbers after the decimal place, it's 15 over 100. We look at both of those and we say, well, they're not both even. We can't divide them by 2. We can't divide them by 3. Maybe we can divide them by 5. 15 divided by 5 is 3. 100 divided by 5 is 20. So you end up with 3 over 20. And now let's take a quarter. Now a quarter is 25%. So a quarter, but if we're going to go step by step with how we get there, so 1 over 4 is the same as 25 over 100, because we scale it up to 100, and then this gives us 25%. So when you have questions in exams, and at the foundation level, when you have these questions, you'll have questions such as, what would you rather have? Would you rather have 3/4 of a pizza, 70%, or 0.72? Now, to compare them in this form is not useful. What you want to do is change them all to percentages, or all to fractions, or all to decimals. So I think in this case, changing them to percentages is easier. 3/4 is 75%. And then we've got 70%, and we've got 72%. So we're going to go with the highest, which is 75%, but in the answer section, we would put 3/4. So that's looking at fractions, decimals into percentages. Now let's have a look at everything connected to that. So let's calculate with decimals, look at simplifying fractions and calculating with fractions. So if we've got decimals, say we have 3.013, 3.0014, 3.0013, and you wanted to write them in order from biggest to smallest. So we have a look. The first numbers are all the same, so well, that's not very useful. The second one is all the same, so that's not very useful. The third one, which is the tenths, well, that's got a 1 and the other ones have got 0. So that's definitely the biggest if I wanted to make that number 1. Then out of these two, that's the same. So that's not useful again. And the last two, well, 4 is bigger than 3. So that's the second biggest and that's the smallest. So in actual fact here, they're already in order. What if we want to, so that's looking at the order of decimals. You keep going along the same way you would with numbers. 304 compared to 405, the 4 is bigger, so therefore that's the bigger number. When we want to add or subtract decimals, what we want to make sure we do with them is we line everything up. So if we had 2.653 plus 0.312, if you notice, I've automatically lined it up. So the important thing is the decimals line up. And then you would add them like you normally would. 3 plus 2 is 5. 5 plus 1 is 6. 6 plus 3 is 9. Dot 2. So you end up with your adding your decimals. So we've got adding decimals, subtracting decimals works in exactly the same way. What about multiplying and dividing decimals? So if I had, say I had 5.8 times by 0.002. Okay, so what you're going to do is you're going to pretend like the decimal place doesn't exist. So we're going to just take the numbers themselves. So we're going to take 58 times 2. Now remember, when we times by 2, we're assuming everything at the moment is non-calculator. When we times by 2, we're doubling. So double 50 gives you 100. Double 8 gives you 16. Add them together, and we've got 116. Right, now we count in the question how many numbers are behind the decimal place. So we've got 1, 2, 3, 4. So in my answer, I have to have 4 numbers behind the decimal place. So this is going to become 0.0116, because I now have got 4, and the only places I can add 0 is in front. Okay, so if I had, let's look at dividing. So if I wanted to do 4.8 divided by 3. Okay. So I'm going to pretend like the decimal place is not there. So I'm going to have 48 divided by 3. Right, 4s into 3 go once, 1 remaining, and I get 16. In the question, now this is a bit trickier, so this is a simplified one. The first number is the number, so here this counts as an add. So what I mean by that is there's 1 behind a decimal place, and here there's none, so it doesn't matter, but what you do is subtract. So we end up here with 1.6 because there's just 1 behind a decimal place. But I'll show you what I mean with something a little bit. Actually, let's do the question that's above there. So if I take this same question that we just did, but instead of timesing, I'm going to divide, and we're going to see what we get. So we're going to change this into a divide sign. So we've got 5.8 divided by 002. So what we do first, we pretend there's no numbers, no decimals. 58 divided by 2, half of 50 is 25, half of 8 is 4, add them up, 25 plus 4 to give you 29. And anything on the first number counts as, so what we're going to have here, so essentially we're going to say how many tens are we multiplying or dividing it by. So over here, this has been divided by 10. So there's one to the left, if you like. So that would take my 29 to 2.9. But then I've got to multiply that by the amount of zeros I'm dividing it by. So what I end up with is 2900. So let's put it here. So 5.8 divided by 0.002 is I take my 29, and it's as if I put the decimal place back, but then I've got to jump it by 3. So then I've jumped it by 1, 2, 3, and those 2 zeros go there. So what's in front of the divide sign is how many decimal place numbers are behind the decimal place, and then you've got to keep timesing it by 10 by the number of numbers after. Because when you divide by a smaller number, you end up with a bigger number. So if I divide sweets by only 2 people, they'll get more each than if I divide it by 20 people. So dividing by a smaller number makes the number bigger. So that's where it can be a bit confusing. Okay, so we've got Aisha. Let me have a look at this question here. So normally decimals are always used with money generally. And people tend to be good at money, so I'm going to leave out the money questions actually. We can simplify fractions. We talked about dividing by 2, then dividing by 5, and then dividing by 10. All right, so let's have a look at ratios which are like fractions. Let's take an exam question. So we've got 32 girls, let's say 32 pupils. We'll use this question actually. 32 pupils in a class. So this is all still under ratio proportion. 20 are girls, right? The rest, 20 are girls, and it's telling you the rest are boys. The rest are boys. What is the ratio? Well, if 20 are girls, that means there must be 12 boys. And because it's asked as a ratio, so you ask for it as a ratio, you put that double dot in the middle. So that's your girls to boys. But what's the problem? It's not in its simplest form because both of those numbers are even. So that's what I'd start with. So then I get 10 to 6 and go, wait a second, they're still even. Can divide by 2 again and get 5 to 3. and that's my simplest form. Now, of course, you could have gone straight from 20 to 5 by dividing by 4, but it doesn't matter if you don't see it, just half and half again. Halving stuff is easy, and we're always going to just divide, we're just going to half things. So in the same way, if I said we wanted to divide something by a ratio, so we've got ratios, so we've gone through, let's go back, we looked at fractions, decimals, and percentages. Fractions, ratios, really similar, right? It's the same sort of thing. We looked at adding decimals, we've looked at ratios, and now let's look at dividing by a ratio just to finish off this section. So if I have, say somebody is sharing, we're going to share some costs in the ratio 1 to 2 to 3. Okay, so 3 friends are sharing a cost of a holiday in the ratio 1 to 2 to 3. Quite an expensive holiday, but let's say the holiday was 1,860. So each of those bits of the ratio count as bits. So person A has 1 bit, person B has 2, so we got 1 plus the 2, and person C has 3. So all together, we've got 1 plus 2 plus 3, which is 6. There's 6 parts to this. This is the total, which matches up to those 6 parts. What we're going to do is take the total, divide it by 6, and that's going to tell us how much one part is. So 1860, and we're dividing it. Remember, we can write as a fraction because we're going to assume this is non-calculator, by 6. And remember what we said, we could half the top and we could half the bottom. If we half the top, half of 1,000, so you could take half of 18 here. You can see you've got 18 here, and that would be 9. Half of 6, which is 3, and you get 0. Or you could look at it as half of 1,000 plus half of 800 plus half of 60. And then half of 6 is 3. And hopefully you can see this now divides nicely. And it will always divide, generally divide nicely in your foundation non-calculator papers. So the exam questions should divide out and make it quite nice. So 9 divided by 3 is 3. 3 and 3 is 1, so you get 310. So 1 bit of this 1,860 is 310. And if I said to you, how much did Carol pay? We'll say Carol is C. Well, she pays 3 bits. 3 bits of the 310. So we're going to do 3 times 310, which gives us 930, which actually works out as what we had above. So that's dividing by ratios. I know we've gone very quickly and a bit bitty. I've just tried to take little bits from all of this whole chapter. Right, so the last bit that we're going to look at is percentages. So percentages. So you see percentages, and we said it kind of looks like a divide and at 100. So it's that the 100 is kind of written in a weird way. So when we have percentages, we said it's always divide by 100 and multiply by the percentage, or change it into the fraction. So if I wanted to work out, for example, 40% of 600, your trick is 10% is always dividing by 10. And then we can half and do different things. And remember, when you divide by 10, you either move a decimal place or you get rid of a 0. If there's a 0, you can get rid of a 0. So if I've got to find 40%, I'm first going to work out 10%. And to work out 10%, I'm going to get rid of a 0. So I'm going to get to 60. And then I'm saying, okay, well, I don't want 10%, I want 40%. But that's 4 times that. So 6 times 4 gives you 24, and I have my 0. So 40% of 600 milliliters is 240 milliliters. So let's take an awkward amount. Let's say we had 67% of 120. So that's not as nice a number. So we kind of go to the stuff that's easy to work out. So we said 10% was dividing by 10. 50% is half, so it's dividing by 2. Okay, so we could start there. So I'm like, okay, so I know what 50% is. So 50% is going to be half of that. So if I take 120 and divide it by 2, so half of 100 is 50, half of 20 is 10, add them up. So 50% gives me 60. 10% we know is getting rid of that 0 is 12. 5% is going to be half of 10%. So 5% is going to be the same as £6. Right, so now I've got 65%. Not quite there, but almost there. What would 1% be? If 10% is dividing by 10, 1% would be dividing by 100. So if we wanted 67%, we've got as far as 65, but we need 2 more percent. So what we could do is either divide it by 100, so get 1.2 and double it, or we can say, how do we go from 10 to 2? We divide by 5. So we could do 12 divided by 5, which would give us £2.40. So there's 2 different ways to do this. So let's say we went to 1%, which was £1.20, because we're going to put the decimal place moves there. So it moves 1 more because we've divided by, let's erase that dot so I don't confuse you, because we divided by 10. And then we need, so that means 2% would be £2.40. So we want 67, so we're going to take 50 plus 10 to give us 60, plus 5 to give us 65, plus the 2 to give us 67. So we've got 72 plus 6 plus £2.40, which altogether gives us £80.40, because not including that one. And that would be 67% of 120 on a non-calculator where you're going step by step. Now, if you were very good with your fractions, you could deal with big numbers, you could do it in one step, but here's how you go take each of the steps through. Right. If we want to increase by a decimal, so that's another type of question that comes up on your foundation paper with percentages. If you want to increase something by 19%, so, or by 20%, or whatever percentage. So increasing, so here's where you have to be really careful. As you read the question, you're looking for words. Increasing, you're adding. You're decreasing, you're taking away. And it's amazing, even sort of my really good higher level students make the mistake of not reading the question carefully enough. So whenever you talk about them, you've got to think about, if I'm increasing it, I'm adding that percentage to it. If I'm decreasing it, I'm taking it down. So if somebody gets, and they won't necessarily use the word increasing, decreasing, they might say better, worse, someone gets better or worse or something. Somebody has more or less. So those are like the exam tips to really think, am I increasing, am I decreasing something? Right, so we're told, let's have a look at these questions. Claire improves her further distance for running by 19%. So she's improving. So we see the word improving, we know we're adding, and we're improving by 19%. At the moment, she can run 4 kilometers. So how much can she run now? Okay. So 4 kilometers, we could turn it into meters if we wanted, but let's leave it as 4. And we want to find 19%. So I think, okay, I know that 10% is dividing by 10. So I know 10% will be 0.4, because when I have a number, there's no zeros to take away, got to move the decimal. So that's my 10%. So that means 1% will be 0.04, right? But I want 19. What's an easy way to do this? So maybe you can see that 20% would be 0.8. And if I wanted to get 19%, I can do 20%, take away that 1%. So I can do 0.8 take away 0.04. Now, do you remember when we take away decimals, we line it all up? And if we're missing something, we can add a 0 in. So we've got 80 take away 4, which is 76. So we've got 0.76, so she's improved. So we're adding that 0.76 to it. So now her new amount that she can run is 4.76 kilometers, because you've increased it, so you've added that amount to it. Right, so let's have a look at maybe one where they're decreasing. Okay, so we've got Ben loses 36% of his Instagram followers. He used to have 380. How many does he have now? Okay, so he's losing. You see this value and you go, okay, must be negative. So we're taking away. So now let's work out 36%. So again, we start off with 10%. 10%, we get rid of the 0 and we've got 38. We say, okay, we could do 1%, but let's have a look. If we get to 30%, is multiplying 38 by 3. So we're going to say 30 times 3, we know is 90. 8 times 3 is 24. So 38 times 3 is going to be 114. Okay, so we've got 380. We've worked out 10% by getting rid of the 0. We've now got 30%. We want to get 6%. We can work out 5% quite easily, because we can take 38 and we can half it. Half of 30 is 15. Half of 8 is 4. Add them up and you've got 19. So now we've got 35%. So we need that extra percent. So do you remember, to get 1%, we divide something by 100. So when we divide it by 100, we're going to get, so if we take the, we're going to get 3.8. Now, because we're talking about followers, that kind of doesn't make sense, because if I work out 1%, I'm going to get 3.8. So we must have to round it to 4. But let's write it exactly as it is. So 1% will be 3.8. So you've got to have that sensibility check. And then we're going to add them all up. So we get 8 here, 9. 9 plus 4 plus 3 gives us 16. So we have 6, carry the 1. 1, 2, 3. So we get 136.8. So that's the amount of followers is lost. So 380 minus 136.8 gives us 200. So we have 380 minus 136.8, which will be 0.0 here. And that's going to give us, I'm not going to do the, you can do the 243. And that doesn't really make sense. So in the last bit of the question here, you would say 233 followers. So you would make it look logically sense, make logical sense, because we talk about people or something where you can't have 0.2. Now, they might give you an extra mark for that. If you left it at 243.2, you should still get the marks. But a sensibility check for you would go, does it make sense? Okay, so that's a very quick summary of ratio proportion for foundation. I've picked out random questions from bits. I hope that was useful. I will do a Welsh board paper tomorrow. If you have already, even if you don't do WJC, then I still suggest that you come and watch going through the paper, because at the end of the day, maths is the same. Maths is other subjects, there's big disparities between different boards, but with maths and science, generally the maths and science is the same. And hopefully this was useful. I will see some of you tomorrow then.